Hello students, today we are going to see about the fully controlled converter and semi-controlled converter step by step using MATLAB simulation software. So while using the MATLAB simulation or open the MATLAB simulation, the pages will be appear. Then we need to click the Simulink icon. So the blank option is created. So now while you click the blank option, the new page will be appear. So first we save the work, applying the save button. We can save the work in any other places. Keep one thing, the name should not have the space between that. Single underscore phase full. So don't leave the space. It will give the error. So we need to save single phase. Now it will be saved. Let me start one by one. First, click library. We require the input AC voltage. So AC voltage source, click it and place in your page. So input is 100, phase degree is 0, frequency is change it into 50 Hertz. Then no need to change anything. Apply, okay. So we required thyristor. So take the thyristor, place in your MATLAB. So click Control R to rotate. So from that we can copy the another 3 thyristor. Now form the bridge. Cathode to cathode, anode to anode, then anode to cathode, anode to cathode. Now connect the input in the bridge. So we require load, use RLC branch circuit. So RLC. So RLC circuit, controller, phase, connect the circuit. So while you click that, the option will be up here. So we take 100 Hertz, 100 ohms as a standard. So the circuit is ready. We need to provide the triggering pulse. So pulse generator. So pulse generator, we must keep here. So before pulse generator, we must see the input waveform. This is the input waveform. So it is a sinusoidal waveform. Start from 0 to 360 degree. The time period. So we fix 50 Hertz. So 1 divided by 50, 0.02 seconds. So the time period is start from 0 to 360 degree. So totally we have 0.02 seconds for total positive and negative half cycle. So for positive half cycle, 0.01, negative half cycle, 0.01. Totally we have 0.02 seconds. So this will implement in the no need to change the amplitude, period 0.02 seconds. That is a time for full cycle. So number pulse width. So let me give more than 25, we give 30. So take the time base. So time period is 0.02 seconds. Pulse width time more than 25 percentage 30. So we need to give the delay. Let me move to the waveform. So here 0.02 seconds. For positive half cycle 0.01 seconds. So we must divide it into 180 degree. 0.01 divided by 180. So this phase delay is for only 1 degree. So into this is our alpha value into 30. Let me take 30. This is our alpha value 30 degree. This is for T1 and T2. So this is given to the T1 and T2 simultaneously. Then, so this is for 0 to 0.1 second. So in negative half cycle, it starts from 0.01. So plus the same in the T1. It is given to T3 and T4. So we need to see the output to measurement. So measurement, we required voltage measurement. Then we need to see in virtual. So we required scope. We required scope. So at the same time, we required go to, this is helpful for us. So while you do the scope, configuration for a property, number of port input 2. So this is given here. This is for input side. We need to measure input side. So we can name it as AC. So while you take the from function to simplify the circuit, we are using this tool. This is not a mandatory one. So now we can run by using the Power GUI. Power GUI. So this is a standard for running the simulation. So we required less time to see the output 0.04. So we need to correct these things. So we layout. Now change the style. Change into white. Change into white. Change into black. And voltage measurement, you must increase the size and take as a red. Apply. Then second one, take it as a blue, apply. So this is our output. So let me use another tools to mean. So we can use the quantitative value. We can use this to view the quantitative value. So use display. So now run the MATLAB. We can get the displayed output. This is 100 is a input and we get the output as a displayed one. We can change into RL value. So by giving 0.5. So now can run, it will reflect in the output. This is because of inductance. Students, one thing you need to know, while you changing the alpha value, we need to open the pulse generator one by one and change the value. Else, you have one short circuit. For example, open the pulse generator and replace the 30 as A. For example, A. You can use any letter. So no need to worry about that. 30 as A. Apply. No need to worry about the warning. Go to the main page. Here you need to initialize A is equal to 30. Now in MATLAB, A is initialized. Now come to the our test page and we get the same output as 30. So for example, I need to change for 45 degree. Simply I go A is equal to 45 degree. Now A value is 45 is assigned. Now I run the value. While you see the scope, we get the 45 degree. Now we move to R. Okay. So 45 degree. Now we give 90 degree. Then will we get the viewable result. So we get the 90 degree output. So by changing the A value, we can able to get the different output value. The corresponding, the voltage is shown in the quantitative one. Here we are seeing the virtual and here we can see in the quantitative one. This is all about the single phase fully controlled converter. While you need to move semi-controlled converter, simply replace the two thyristor and with diode. Go to library and click diode. So select this diode only. So replace here. So now the bridge is created. So T1 and T2 is connected. So we need to complete the bridge. So our semi-controlled converter is ready. So the alpha 1 is for T1 and alpha 2 for T2. The diode, we did not require the triggering pulse. Let me continue as it is. So we get 90-degree output. Let me reduce the main page. A is equal to 45-degree. Initialized A is equal to 45. Now run the circuit. We get the output. So by this, we can simply get the different output value without selecting each pulse generator and change the value. We can easily get the output. So next class, we see about the three-phase semi and fully controlled converter. Thank you.